Welcome to all. As I told in the last class, that is in class number 66, we considered this question already in the last class, where, if you remember, I considered x from this side. That is the best solution. Because when you consider x from this side, you get triangle. This is all I explained last time. Now, I told last time that I will solve the same question again, alternative solution. What will happen if you take x from this side? I told the reason once again. See, to avoid the trapezium, you can look this side. X from this side is ideal. But I told last time, in case loading is something like this, then when you take a section, whether you look right side or left side, you have to face the trapezium. Therefore, for learning that one, I told next class, I will consider x from A and solve it. Now, last time question I remember, span I don't remember, I think 6 meter span I think it is, loading I forgot. I changed the question. Okay, now new question, same as last time, numerical change. So intensity is 0 at right end and maximum left end, see question given here. Even I considered one hinge, one roller, that is not a problem. Next time again I will take simply supported. Why? I already told you, horizontal reaction has no bending effect. Now, so question given here, go through question. This is already solved last time in class number 66. Example number Roman 5, 1B2. Fully solved. Only change is 8 and 15. Some other numbers are there. So, I am not going to explain this one. You just solve, yourself only solve. Which one? The traditional solution or easy solution by taking x from this side. But anyway, before that one, first support reaction, hinge vertical and horizontal, roller only normal, that is vertical. I wrote everything. Take moment about A, you get VB, sigma V0 VA. I even explained also total load is half into base into height, which will act at 1/3 from here and 2/3 from here. These all already explained. Earlier classes thoroughly explained. Last time again explained. So now it is for you to complete it. So correctly, first get reaction. See, this is common for both. Whether you take x from A or x from B, reaction calculation remains same. Now you go to diversion. Now I will go for solution 1. I will start now to draw SFD. See, next will be, see, to draw SFD and BMD. Remember, by basic approach. By basic approach. That is, we have to even prove how is the variation. Shortcut I will tell in the next class, class number 68. Okay, now I will first go for option 1. What I will do is, same as last time, I will consider x from B. So, exactly same as last time. So, I will write a solution here and then leave it for display and then go to solution 2. Now ready to draw SFD and BMD. Solution 1, ideal and most preferred. That is, we will consider x from here. See, x from that end, don't by heart right side. X from that end where intensity is 0. So that when we consider shear force at xx and BM at xx, when you look that side, we have to consider UBL represented by a triangle. See, represented by a triangle. This is the best solution. Okay, start. Consider section XX between A and B at x from B, WX be the intensity at XX. Then I told you, directly you can write W suffix x, stand here. 15 divided by 8 into x. Or if you want, you can write 15 divided by 8 equal to W suffix x divided by x. You get Wx. This is told so many times earlier. So you should do that one. First of all, for an engineering student or engineer, this is nothing. Okay, now ready. Now we will go for solution systematically. I will write it. I wrote everything for shearing force diagram, all calculations, including diagram. Already same question over last time. I told instead of 8 meter and 15 kN per meter, some other values are there. So referring that one, study again and again and then thoroughly complete this one. Our today's class purpose is to solve the question when you take x from a. But why I am solving this one? Just to show you that this is actually easier and ideal. That is unwanted or unnecessary going for trouble. But I told the reason. Even though it is actually not ideal, it will give you good concept. The purpose is that one. When you have to consider UVL represented by a trapezium. Okay. Now I will go to next part of this one, BMD. Yes, BMD also ready. I already wrote it fully. Everything referring to previous class. Make a fair copy. Thoroughly understand. Now you have to draw SFD BMD for this one. Okay, I will draw that one now. Everything I wrote, correctly study and get complete mastery on this one. Okay, now as I told, no explanation. Now come to the very purpose of today's class, that is considering x from a, so that you will learn lot of things. Okay, we will start now. Alternate solution, I will start. Solution 2 or I told alternate solution. Note, not preferred for this example. We already solved the easiest way. But important later, already explained. When you cannot avoid trapezium, this example will help you a lot. Okay. That is, remember, x from here. That is x from A. So, start solution. I am not entering reactions because again I am entering. Consider section xx, I forgot to write xx only. Xx between A and B at x from A. Let W suffix x be the intensity here. Now you need this one. See, when you apply similar triangles, I think all are knowing you should stand here. So 15 divided by 8 equal to W suffix x divided by not x now, divided by 8 minus x. You get the value of W suffix x in kn per meter, or as per the mathematical trick I told, stand here 15 by 8 into 8 minus x. Now ready for SFD and BMD. That is not SFD BMD drawing, calculations for SFD BMD. Now an important note, see 15 kn per meter, 0 here. This is a triangle now, see loads are here. This is the loading, okay, loading is here. When you take section XX, when you look this side, you are going to get trapezium. This ordinate is 15 kn per meter. This ordinate, just now we got 15 by 8 into 8 minus x kn per meter. Distance between these 2 points is x. Now, when you find shear force BM here, we require total load and also moment of that load about xx. So, when you want total load, it is area of the trapezium. Go back to earlier class, very thoroughly explained somewhere, search it. Area of a trapezium equal to sum of the two parallel sides divided by 2 into distance between the two parallel sides. Okay, I'll write once again for you. I should not write randomly. If this is a trapezium here, see, sorry. Just to, I should not give because already over earlier. Okay, I'll do one thing now. Anything, I'll take this as y1 and y2. Base length is some length, anything, say L0. This I told earlier. The area of this trapezium is sum of the two parallel sides. I put y2 here. y1 plus y2 divided by always 2. See, divided by 2 into distance between the two parallel sides is L0. Then, suppose you want to CG. Suppose you want CG from here. See, I told earlier, stand here. From where you want CG, start from there. That side first. Y2 plus twice of other side. Divided by sum of the two parallel sides. Y2 plus Y1 into distance between the two parallel sides, L0 divided by 3. Now, suppose I want from this side. Then, start from here. Y1, that parallel side, plus twice of other parallel side y2 divided by sum of the two parallel sides y1 plus y2 into distance between the two sides is L0 divided by 3, not 2 now, divided by 3. Okay. Therefore, later when you write expression for SFBM, I will not explain once again. When you want shearing force here, see, this reaction you consider minus this much load we want. So that much load is this much area equal to 15 plus 15 by 8 into 8 minus x divided by 2 into x will give total load. Okay, then when you write expression for BM here, reaction into x we will write as usual minus moment of this total load about this point is total load, already I told just now, 15 plus 15 by 8 into 8 minus x divided by 2 into x into this distance we want. That distance will be, see, from here, distance will be this side, 15 by 8 into 8 minus x plus twice of other side, 15, divided by sum of these two sides multiplied by distance between the two sides divided by 3. Thoroughly understand again and again and solve. Okay, now I will go to next part. Or one more concept. Those who find difficulty for trapezium, see, your section x-axis here. When you look this side, you get a trapezium. Trapezium, I will tell my students, never be afraid of trapezium. Anyway, there are people, actually more than 90% people, they will tell if trapezium is there, divide into triangle and rectangle. But I don't recommend it. You will learn trapezium, what is there. Or suppose you are used like that, then no problem. What you do is, or see, you divide into parts. Then see here, this is already known for you. 15 by 8 into 8 minus x, this total is 15 kN per meter. Total. Therefore, divide into part. This is a rectangle now of 15 by 8 into 8 minus x kN per meter. Total 15. So this will be total 15 minus 15 by 8 into 8 minus x kN per meter. Or that you can make some simplification later. Okay, that is second alternative. Then remember, when you take shear force here, this load and this load both. This load is a rectangle UDL, that is x into this ordinate, here half into base into height. Moment, for this UDL, distance is x by 2. For this uniformly varying load, see, for this one, CG will be here. For this one, CG will be here into 2 by 3 of x. So I will solve both the ways so that everybody, those who are used to only for rectangle and triangle, they do not want trapezium, they can use my class also for further learning. Okay, I will now continue and go for SF and BM. We will continue. See, I told reactions are entered here, section X has taken, all these are already explained. I have gone for both the options. One option, take X from here, this intensity I told, how you got it, or you can divide into parts. Both of them are thoroughly explained. So go through again and again. Now start. Shear force here. Look this side. Plus 40 minus this total load. 15 plus 15 by 8 into 8 minus x divided by 2 into x. And then now you simplify it. See what I have done is I have taken the 8 common here, then divide by 8, then simplified this equation. Simple high school level mathematics. Simplify it. You get the expression for Vx. Then Bm, see I wrote earlier because if I write everything in front of you, one more thing, so many calculations are there. Sometimes little this side, that side. Then what happens? Again and again I have to rub. So when it comes to high school level mathematics, I stopped it here. Stopped explaining. Next, Bm here. 40 into x minus moment of this total load. Total load is 15 plus 15 by 8 into 8 minus x divided by 2 into x is the total load into from here to here distance, that is equal to this ordinate plus twice of that ordinate divided by this ordinate plus that ordinate into distance between them x divided by 3. Now, simple calculation I made here, I reduced. But one important concept here, see, when you write here 15 plus 15 by 8 into 8 minus x, 15 by 8 into 8 minus x, 15, these two terms will get cancelled. One advantage. So, when you simplify, just take this 2 x by 2 outside and then x by 3 is there. Simplify, you get this equation. This you have to thoroughly practice. Good mathematical practice for you. Or, suppose people who don't want trapezium, they want triangle and rectangle. For them, already I explained this one. See, this is same this ordinate. See, whatever this ordinate here, same ordinate here. 15 by 8 into 8 minus x. This will be from 15 subtract. Simplify. 15 by 8 into 15 is 15 minus 15, 0. It will become 1.875x. If you simplify this one, it will become 15 minus 1.875x. Some plane going, okay. Now, okay, forgot to write x here. This is x, start. BM here, a shear force here first. Plus 40 minus this load and this load. This load is x into this ordinate. This load is half into x into this ordinate. I wrote everything here, see. Simplify, you get Vx equation. BM equation. Plus 40 into x minus moment of this load, x into this ordinate into center x by 2 rectangle, again minus half into x into this ordinate 1.875x into CG will be here, from here to here will be 2 by 3 of x. Where is it? Here, 2 by 3 of x. Now simplify. Very simple mathematics. Simplify, you get mx equation. Now observe one thing. We got Vx expression here and Vx expression here. Both are same. Again, we got mx here, both are same. Now for both of them, common continuation. Whether you consider this way or that way, finally your expression for shear force and bending moment at xx remains same. Now what I did is, I checked this one. How I checked is, I substituted x equal to 8 meter. I should get shear force at B. See, in front of you, I'll check it now. Safer side, see. 40 into 8 minus 7.5 into 8 square plus 0.3125 into 8 cube. No, that is a bending moment. I am seeing wrong equation here, see. 40 minus 15 into 8 plus 0.9375 into 8 square gave me minus 20, correct. And when I put x equal to 8 meter there, bending moment, 40 into 8 minus 7.5 into 8 cube plus 0.3125 into, oh sorry, not 8 cube, it's 8 square. Okay, 40 into 8 minus 7.5 into 8 square plus 0.3125 into 8 cube. I got 0. I applied one more check. For this beam, I know that shearing force at center is 20 minus half into 4 into 7.5. That is minus 5. At center, shear force is minus 5 and BM is 15 into 8 square divided by 16. 60. I substituted x equal to here, how much? 4 meter. See, I got 40 minus 15 into 4 plus 0.9375 into 4 square minus 5. BM 40 into 4 minus 7.5 into 4 square plus 0.3125 into 4 cube. 60 kN meter. You never bother how I got 60. Some tricks are there. That all I will tell later in objective type questions, not now. Right now, our purpose is to systematically draw SFD BMD. Now, I will conclude this one by drawing SFD BMD. Okay. Now, the closing part. First of all, I don't have to explain. Start. Vx equation, mx equation written at x from here. Now remember, you never bother whether you are considering trapezium or rectangle and triangle. But x is from A, important. Equations. Start. Shear force calculation. Put x equal to 0 in Vx equation, shear force at A. Put x equal to 8 meter, shear force at B. Over. Now you have to locate the point where shear force is 0. For that, equate Vx to 0. This equation, when you equate to 0, you get a quadratic equation. Nowadays in primary school it comes. On solving, two positive value will come here. One of them is plus 11.8301, other is plus 3.3812. Now, this is I have written rearrange this one, okay, just to avoid mistakes. But your x is more than, say from here, x is more than 0 but less than 8. So 11.8301 meter is not applicable. It is, you cannot have a beam here, beam bending here, maximum BM somewhere there. How it is possible? Okay, so x equal to 3.3812 meter. Remember, once again note, from A, very important, from A it is. Okay. Now, BM calculation. In the mx equation, x equal to 0, you get BM at A 0, x equal to 8, BM at B. To get maximum BM, actually you know maximum BM is at this point only. Still, to be perfect, bending moment concept. For mx to be maximum, dmx by dx equal to 0. Differentiate mx equation with respect to x and equate to 0. See, you will get same x value. Again, non-applicable, 3.3812 meter. So, maximum BM is at that much from A. Substitute that x in the mx equation, you get maximum BM. Lastly, SFD BMD, already told, I think 7-8 times now for this question. So, neatly add on SFD BMD. One small important information. See, once you get Vx equation, it is very simple. See, plus 40 minus 15 plus 15 by 8 into 8 minus x divided by 2 into x. You get this equation. For BM, you don't have to struggle. You can integrate this expression for Vx, and with the constant C1 and with the constant at C1, put the boundary condition, then you will get the expression for Vm. You can integrate this one. When you integrate, 40 becomes 40x minus 15 becomes 15x square by 2, 0.975 into x square becomes x cube by 3 plus constant c. Boundary condition. When x equal to 0, what you can tell? Bm equal to 0. That's all. If you substitute, your constant will become 0. So you get same equation. That all principles I will tell after our main course is over. Those who are interested in learning, remember, you will learn a lot from me if you seriously go through all the classes and thoroughly understand, and same day make fair copy. Somebody will tell this much lengthy, why required? Okay, say why required means not required. You go for shortcut, but shortcut and easy approach will be very comfortably used provided basic concept is clear. So I believe in full basic concept, understanding a full basic concept, then go for shortcut. You will be surprised later how fast I can go to shortcut. Not now, later I will tell. Okay, thank you for going through this mega class. Hope all will study thoroughly and get ready for next class. Okay.